My name is A. Science Reddy. I am from EC branch. Today my topic is T parameters in terms of H parameters. First we want to discuss about T parameters overview. Definition of T parameters. T parameters means transmission parameters. It describes two-port networks commonly used in transmission line analysis, high frequency circuits. Form of representation. T parameters relate the input and output voltages and currents. We can see the equations on matrix form of T parameters. V1 equals to T1 T2 into V2. I1 equals to T21 T22 I2. Here T11 means input impedance parameters. T12 means reverse voltage transfer parameter. T21 means forward current transfer parameters. T22 means output admittance parameters. Now we can see the overview of H parameters. Definition of H parameters. H parameters means hybrid parameters or another way to describe a two-port network. Form of representation. H parameters use voltage and current as variables, mixing both input and output quantities. You can see the matrix form of H parameters. V1 equals to H11 H12 I1. I2 equals to H21 H22 V2. Here H11 means input impedance parameter. H12 means reverse voltage gain. H21 means forward current gain. H22 means output impedance admittance parameter. Now we can see the converting of T parameters into H parameters. Objective: express T parameters in terms of H parameters and vice versa. Conversion relations: H11 equals to H1 T11, H12 equals to T12, H21 equals to H21 equals to T21 by T22, H22 equals to 1 by T22. Now we can see the conversion equations. The general equations of T parameters is given as V1 equals to AV2 minus BI2 and I1 equals to CV2 minus DI2. We can take equation 1 and 2, these two equations, and the general equations of H parameter is given as V1 equals to H11 I1 plus H12 V2, I2 equals to H21 I1 plus H22 V2. We can consider these equations as 3 and 4. From equation 4, I2 equals to H21 I1 plus H22 V2. Convert these equation into as equation 2. H21 I1 equals to minus H22 V2 plus I2. I1 equals to minus H22 by H21 V2 plus 1 by H21 I2. Consider this as equation 5. Substitute equation 5 in equation 3. V1 equals to H11 into minus H22 by H21 into V2 plus 1 by H21 I2 plus H12 V2. V1 equals to H12 to H21 minus H22 H11 by H1 into V2 plus H11 by H21 into I2. Consider equation 6. Now compare these equations 1 and 2 into with 5 and 6. Then A, B, C, D. This is a matrix form of T parameters equals to H12 H21 minus H11 H22 by H21 minus H11 by H21 minus H22 by H21 minus 1 by H21. Here A equals to H12 into H21 minus H11 into H22 by H21 and V equals to minus H11 by H21. C equals to minus H22 by H21. D equals to minus 1 by H21. Hence we find the T parameters in terms of H parameters. Now let us see an example of two-port networks with following H parameters. Given H11 equals to 2 ohms, H12 equals to 0.5 ampere per volts, H21 equals to 1.2 s, H22 equals to 0.8 s. H11 equals to 2 ohms, H12 equals to H21 equals to 1.2s, H22 equals to 0.s. Now we can convert these H parameters into T parameters. Let us consider the step 1. Use the 0.5 amperes per volts E conversion formulas from the previous relationship. We know that H11 equals to H11T11 equals to H11T12 equals to H12 minus H11. H22 equals to T12 equals to H12 minus H11. H22 comma H21 equals to H21T21 equals to H21 T22 equals to H22T22 equals to H22. Let us consider step 2. Plug in the values. Calculate T11 is to H11 equals to H11 equals to 2 ohms. T11 equals to H11 equals to 2 ohms. Calculate the T12 and the H12 equals to H12 minus Hi1. H22 equals to 0.5 minus 2 minus 0.8 equals to 0.5 minus 1.6 equals to minus 1.1 amperes per volts. T12 equals to Hi2 minus Hi1 and into H22 equals to 0.5 minus 2 minus 0.8 equals to 0.5 minus 1.6 equals to 1.1 ampere per volts. Calculate T21 comma T21 is to T21 equals to H21 equals to 1.2 s. T21 equals to H21 equals to 1.254. Calculate T22 is to T22 equals to H22 equals to 0.8 s. T22 equals to H22 equals to 0.8 seconds. Finally, T parameters are T11 equals to 2 ohms, T12 equals to minus 1.1 ampere per volts, T21 equals to minus 1.1 ampere volts, T21 equals to 1.2 s, T22 equals to 0.8 s. From this example, the T parameters corresponding to the given H parameters. Now we can see the applications of T parameters and H parameters. T parameters are used in high frequency circuits, transmission lines, and used for modeling and analyzing signal transmission. H parameters are used in amplifiers, small signal analysis in electronics, used in transistors model and other activity components. Now the advantages of T parameters. These are simplified analysis of cascade networks, direct relationship with incident and reflected waves. Advantages of H parameters. These are advantages of real number representation at audio frequencies, easy of measurement, convenient for transistor modeling, applicability in low frequency analysis. H parameters are particularly useful for analyzing circuits at low frequencies, where the effect of parasitic capacitances and inductance are minimal. Conversion between configurations. Now we can see the summary. T parameters and H parameters are both circular curical for understanding network's behavior. Conversions between T and H parameters allows flexibility in analysis and simplifies circuit design. The formulas for conversion enable easier handling for practical circuit problems. Thank you.